Some people need to wake up their computers remotely with wakeonlan. In this video, I will talk about how to implement wakeonlan by yourself. I assume whoever interested in how wakeonlan is implemented already know how to configure the settings on your computer and BIOS. And there are many tutorials online too, so I won't spend too much time on it, but I will put some information in the description. So here's how to set up on Windows and also on Ubuntu. There are already some existing apps for wakeonlan, and wakeonlan is what I usually use. There are even online wakeonlan services, such as this website, which allows you to wake up your computer through the internet. You don't have to be really in your local network. So you just need to enter a MAC address and IP address. And you can even embed the parameters in the URL and bookmark the URL. This requires your network to be open to the public internet, which could be risky. So if you have to wake up your computer remotely, a VPN may be a better choice, and I will talk about it later. You can use applications such as Wireshark to verify that a magic packet has been received. Magic packet is what is used to wake up a computer. Wireshark is available on Windows, Mac, and Linux. I like to use wakeonlan. You can install it with sudo apt install wakeonlan. And you need to get your MAC address. And then just type wakeonlan MAC address. Now Wireshark is empty, and if I send this packet, Wireshark will detect a wakeonlan packet. Now I'm using Ubuntu. I have another Linux machine open here, so let me clear this first. So if I send the packet to myself to the Ubuntu machine, the other Linux machine will also detect the packet, since it's broadcasting. Magic packet is what is used to wake up a computer, and it's super simple. From Wikipedia, we can see that a magic packet is just 102 bytes. It consists of 6 bytes of 255 and 16 repetitions of the MAC address. Wireshark wiki page also contains some information about wakeonlan magic packets. The 6 bytes of FF is called synchronization string, and the rest of the 16 duplications of the MAC address is target MAC, which is the MAC address of the computer you want to wake up. The FF here are in hexadecimal. In hexadecimal, F corresponds to 15 in decimal and 4 ones in binary, and FF corresponds to 255 in decimal and 8 ones in binary. And I will do the demonstration with Golang. So here what I'm doing is I turn FF from string into hexadecimal and print them in hex, decimal, and binary. If I run this, we can see FF, 255, and 8 ones. And we know that the synchronization string is just 6 bytes of FF, which look like this in hexadecimal. So what we can do is we repeat 255 6 times and turn it into a byte array. Or you can just use string repeat to repeat FF 6 times. The \x is just for indicating that it's hexadecimal. The next step is to repeat the MAC address 16 times. So now suppose we have MAC as a string, then we can use string repeat to repeat it 16 times, and convert it to hexadecimal. And lastly, we just need to combine the 2 byte arrays. Here is a sample code. A magic packet is typically sent using UDP. And all we do after creating the magic packet is to send the packet to the target IP and port using UDP. I'll copy it and paste it here. So for MAC address, let me use the MAC address of my virtual machine. I will need to remove the column. This piece of code is not the final version. The final version will handle the columns by itself. Okay, so it's running. So on my virtual machine, I already opened Wireshark. So, and it has a WOL filter. So if I run this, you can see a magic packet has been captured. So here's the main logic of constructing a magic packet or wakeonlan. And I turned it into a command line app with main.go and wol.go. The main logic is in wol.go, and main.go is just a argument parser. So I will run go build, and you can see that we have a wol.exe since it's a Windows computer. So I will run wol.exe with the MAC address. Since I already handled the column in the string, so I don't need to remove it. Let me run this again. Oh. Mac. So as you can see, we're receiving the magic packets in the Ubuntu Wireshark. This is the content of a magic packet, and you can visualize it in Wireshark. It's much more than 102 bytes. If you click on the sections, the corresponding bytes will be highlighted. This includes the destination, the protocol, but the 102 bytes we made is actually the last section, which consists of 6 bytes of FF and also 16 repetitions of our target MAC address. I also made the Python version of the wakeonlan command line app. So if you run Python wol.py following the MAC address of my virtual machine, you can see that a magic packet has been detected. You can find all the code on GitHub. Right here. To prove that receiving a magic packet can really wake up a computer, I'm gonna do a real-life demo using my PC. I'm in the code repository now, and I'm gonna build main.go. WOL is the executable, and I'm going to execute it with my MAC address. 3, 2, 1, go. I also made a web app for wakeonlan, which you can wake up your computer through a browser on your phone instead of typing the commands. You can, so let me open Wireshark. So you can send the magic packet in one click. And yeah, the magic packet is detected. If you need to remotely wake up your computer, you can use a VPN to connect back to your home and access the website hosted at home and wake up your computer. I use a Raspberry Pi as my VPN server. I've made a video about it, and there are plenty of tutorials online too. If you are interested in this web app, please check out my next video, which I will explain how to deploy it and how to use it.